Hey, what's up, guys? Chung here again. So, I just want to talk about this problem 418 sentence screen feeding one more time because I want to introduce another like a DP-like solutions for this case, even though it's a bit slower than the other one than my previously uploaded videos. But to me, I think this DP-like solution is more like intuitive for me. Okay, let's quick read through the problem here in case for you guys who haven't seen my watch my first video. And so you're given like a rows and columns, right? The 2D screens here and a sentence by a list of non-empty words, and you need to fit in those words into this sentence into this screen here. Some of the rules here is that, for example, here uh, on each row between any two word there has to be a space. Second, you cannot split the words into two words, which means you have to you have to remove the second words to the next word into the next row here. And if you watch it closely, so on each row, it has to be starting with a different with a different with a different word, right? And one way of improving this solution is improving our code is to we can pre-calculate since we have n words here, right? We can pre-calculate for the current word I. If a row start basically if the current row starts with the sentence the word I. mm, Basically how many first okay how many times we can the current sentence can be fit in within the starting from this word and for to try to fit in everything into for this entire row. How many times we can fit starting from this word. And the next one is the after finishing this word, what's the next word of the next row? Basically, that's the two pre-calculated arrays we want to pre-calculate. So what I'm trying to say here, we're gonna have like a next index. Hmm. Okay, so for the times and here it's gonna be the 0 times n, right? And then the times also 0 times n. Okay, so I think this is like easy to understand, right? Basically starting from the current word, the ice word, right? And for the current for one row, since the column is fixed, so basically starting from the current row, starting from the current word, how many times we can fit the entire sentence into one row. Okay, so this is what this times array is storing. And the tricky part is this one, the next index. Basically, this is storing like starting from the current word after fit after fitting the current row. What's gonna be the next? What's gonna be the index, the word index for the next row? Why is that? Okay, I'll show you how can we use that. Basically, assuming we have this two pre-calculated list, right? And then all we need to do is like this. We have answer equals to 0, and then we have a current index here, right? Current index is 1. So all we need to do is we just do a we just loop through the rows here. Okay. The answer is we always start from the first one, right? So the times hmm, okay. So it's going to be current index, right? So basically at the first row, since the current index 0, it means that starting from the 0, right? Starting from the first word, how many times we can fit in with the first row, right? Since we already pre-calculate this one for the starting with the first word, right? And now after this one, what's gonna be now we're moving to the second row, right? So on the second row, what's gonna be the starting word for the second row? That's what we need to use with the next index here, right? So we keep updating the current index with the next index of our current index, right? And then in the end, we simply return the answer here because this next index array is basically for the current index of word. It's always pointing to the next one. That's how we just using this next index to updating what's the next current index, what's the next starting index. So it's going to be the word index. I would say a word index. Okay. Right. So that's the word index to start with. Start with this word. We have this answer. And then once we move to the next row, we just need to use whatever we pre-calculate in here with the current word index. And then this will give us the word index for the next row. And we'll keep doing this. Okay. And now we just need to fill in those two lists. Okay. And for I in range n, right? Uh, so we're gonna have a current index equals to I, right? And then starting from here, and we'll have a times equals to 0, and then a length. I'll use a current length, okay, equals to 0. Basically, what I'm trying to do is well, the current length plus the length of the sentence dot current index is not greater than the columns, right? If that's the case, first I update length with this length plus 1 since we're going to add the space, okay? And then we're going to increase the current I. That's our like the word index, okay? And if the current I is equal to n, then we know, okay, we have reached the end of the sentence. We simply increase the time by 1 and then we reset the current I back to 0, okay? And once we're finishing this while loop here, right? And then we have the current I will be the next the word starting for the next row. Okay, so that's next index I is going to be the current I. And also same thing for times, right? Times I will be time. Yeah, I think that should work. Just work. Let's try to submit it. Yeah, as you can see, this problem is not, sorry, this solution is not a very fast one because it only beats less than 10%. But for me, at least, I think this solution is a little bit more easier to understand. Basically, we just pre-calculate two lists here. First one is the starting from the current word after filling the entire row. What's the next what's the word index for the next row? And the second one is that the times it can be filled for the current row starting at the current ice word. And then once we have those two, we can simply use this kind of like tricky or a clever way of iterate through the rows while summarize the times also, and we also update the next rows word index. Mm, yeah, I think for this one, I don't know what else I want to talk about. Basically, this is a different way of solving this problem, and you can call it it's not a DP, it's just like pre-calculation stuff, you know. I think in order to for DP problem, I think you need like the state transitions function, like the DPI equals to DPI minus one, blah blah something. But this one is just like a pre-calculation, right? And then you just use the pre-calculated results, try to come up with the final answer. Yeah. Um, yeah, it's cool. I think that's it for this problem. Yeah, thank you so much, guys. And I hope you guys enjoy it. Okay, see you. Bye bye.